Vietnam, 1968. A Huey gunship banks low over the tree line, and for half a second, the jungle below seems to dissolve. Not from a bomb, not from artillery, from a single weapon mounted in the aircraft's door, spinning 6 barrels so fast that the sound isn't recognizable as gunfire at all. Witnesses on the ground would later describe it, not as a rattle or a crack, but as a deep, continuous buzz, like a chainsaw the size of a truck. In the space of 3 seconds, that weapon could put more rounds into a single position than an entire infantry squad firing standard rifles for a full minute. This is the M134 minigun, and more than 50 years after it was first fielded, the United States military is still putting it into service today. This is the story of a weapon built to solve a problem that seemed almost impossible on paper. How do you put enough lead into the air, fast enough, to guarantee a hit against a target you might only see for a fraction of a second? And it's the story of why, in an era of guided missiles, drone strikes, and precision-guided munitions, the answer the U.S. military settled on more than half a century ago is still, in certain situations, the best tool for the job. To understand why the minigun exists at all, you have to go back to the specific and brutal math of aerial warfare in the early 1960s. American helicopters flying escort and gunship missions faced an enemy that rarely stood still and rarely stayed visible for long. A gunner engaging a target from a moving aircraft, often banking, often taking fire, had an engagement window measured in single seconds. Conventional machine guns of the era, firing at rates around 550 to 850 rounds per minute, simply couldn't put enough rounds on target in that window to guarantee a kill, especially against fleeting targets glimpsed through jungle canopy or drainage ditches. Pilots and gunners needed a weapon that could compensate for human reaction time and aiming error with a sheer, overwhelming volume of fire, one dense enough that even an imprecise burst would still connect. This was not a new problem in military history. In fact, it was almost the same problem American engineers had wrestled with a century earlier, during the Civil War, when Dr. Richard Gatling designed his hand-cranked multi-barrel Gatling gun specifically to overwhelm a target with volume of fire that no single-barrel weapon could match. Gatling's original design used a rotating cluster of barrels turned by a hand crank, each barrel firing in sequence as it rotated past the firing position, a mechanical arrangement that allowed sustained fire far beyond what any single-barrel weapon of the 1860s could achieve without overheating or fouling. The Gatling gun saw limited but notable use in the later stages of the Civil War and went on to serve various armies around the world for several decades afterward. The Gatling design had faded from military relevance by the early 20th century, replaced by more compact, gas or recoil-operated machine guns that didn't require the mechanical bulk of a rotating barrel cluster. Weapons like the Maxim gun and its successors, which achieved reliable automatic fire from a single barrel using the energy of each fired round to cycle the action. For roughly half a century, the rotary barrel concept was treated as a historical curiosity, a clever solution from an earlier era of firearms technology that modern engineering had simply surpassed. But by the early 1960s, engineers at General Electric, working under a U.S. Air Force research contract, revisited that century-old concept and asked a simple question: what if you replaced Gatling's hand crank with an electric motor and pushed the rate of fire to numbers no conventional machine gun could physically achieve? The timing was not a coincidence. Jet aircraft and helicopters of the era demanded weapons capable of extraordinarily high rates of fire for exactly the kind of fleeting, high-speed engagements that ground-based infantry rarely encountered. And the old rotary barrel concept, once considered obsolete, suddenly offered a mechanical solution that no conventional single-barrel design could match. The engineering challenge here was almost entirely about heat and mechanical stress. A standard single-barrel machine gun, firing at high sustained rates, faces a serious problem. The barrel absorbs enormous heat with every round fired, and past a certain point, that heat causes the barrel to warp, wear out prematurely, or in extreme cases, cook off a chambered round without the trigger even being pulled. The solution GE's engineers arrived at was to spread that heat load across 6 rotating barrels instead of 1. Each barrel fires only once per full rotation of the barrel cluster, giving it 5 full rotations to cool before firing again. This meant the weapon could sustain rates of fire that would destroy any conventional single-barrel machine gun within seconds, without the barrels ever reaching the same catastrophic heat buildup. The mechanism itself was driven not by the recoil or gas pressure of firing, unlike almost every other machine gun in American service, but by an external electric motor. This was a deliberate and crucial design decision. By decoupling the weapon's cycling from the firing process itself, engineers eliminated the jamming and reliability issues that plague gas or recoil-operated weapons pushed to extreme rates of fire. The motor simply rotates the barrel cluster at a fixed, controllable speed, and the mechanical timing of feeding, firing, and extraction is handled entirely by that rotation. The trade-off is that the weapon requires an external power source, typically the aircraft's own electrical system or a dedicated battery pack, something no traditional infantry machine gun has ever needed. This externally powered design solved a second major problem beyond simple heat management: consistency. In a conventional gas or recoil-operated weapon, the force cycling the action comes directly from the pressure of the round just fired, which means any variation in ammunition quality, any minor fouling in the mechanism, or any drop in gas pressure can cause a misfire or a failure to fully cycle. Because the minigun's rotation speed is dictated entirely by the electric motor rather than by the ammunition itself, the weapon's cycling remains mechanically consistent regardless of minor variations in individual rounds. Feeding, chambering, firing, and extraction all happen at fixed points in the barrel cluster's rotation, driven by cams and a rigid mechanical timing sequence rather than by the unpredictable physics of each individual cartridge. This is a large part of why the weapon earned a reputation for exceptional reliability, even at rates of fire that would destroy the internals of almost any conventional automatic weapon within seconds. The resulting weapon, designated the M134, could fire at a selectable rate of either around 2,000 or 4,000 rounds per minute, with later variants and export models capable of even higher rates approaching 6,000 rounds per minute. To put that number into perspective, a standard infantry machine gun like the M60, widely used by American forces during the same era, fired at approximately 550 rounds per minute. The minigun, even at its lower selectable setting, was firing nearly 4 times faster. At its highest rate, it was firing more than 7 times faster than a conventional squad automatic weapon, a volume of fire so extreme that a single 1-second burst could put more than 60 rounds into a target area roughly the size of a dinner table. The selectable rate of fire itself was a deliberate operational feature rather than a simple mechanical limitation. Gunners could choose the lower rate for extended engagements where ammunition conservation mattered, or switch to the higher rate when maximum immediate saturation of a target area was the priority, such as during a fast helicopter pass over a suspected enemy position where the aircraft might only be within effective range for 2 or 3 seconds total. This flexibility meant a single weapon system could adapt to dramatically different tactical situations simply by adjusting the electric motor's rotation speed, something no gas or recoil-operated weapon of the era could replicate, since their cycling rate was fundamentally tied to the physics of each fired round, rather than an independently adjustable mechanical input. The weapon itself weighed approximately 85 pounds unloaded, chambered in standard 7.62 by 51 mm NATO ammunition, the same round used across much of the American arsenal at the time, which simplified logistics considerably, even as the weapon's ammunition consumption rate created entirely new logistical headaches. A single minute of sustained firing at the highest rate could burn through 4,000 rounds, an amount of ammunition that would last a standard infantry unit for an entire engagement. This is precisely why the minigun was never issued as a standard infantry weapon carried by a single soldier. It was, from its very first deployment, a crew-served or vehicle-mounted system, requiring either an aircraft's ammunition feed system or a ground-based mount with a substantial ammunition supply to feed its appetite. Early operational use came almost immediately in Vietnam, where the minigun was fitted to UH-1 Huey gunships, AC-47 gunship aircraft nicknamed Puff the Magic Dragon, and later, the more heavily armed AC-130 gunships that remain in service in updated form today. Door gunners and fixed forward-firing mounts alike use the weapon to devastating effect during close air support missions, laying down suppressive fire across tree lines and enemy positions with a density that conventional machine guns simply could not replicate. The AC-47, in particular, became legendary among American ground troops for its ability to circle a besieged position and provide what amounted to a continuous wall of fire along a defensive perimeter, buying time for units that might otherwise have been overrun before reinforcements arrived. Ground troops who called in support from minigun-armed gunships during the war frequently described the experience in almost reverent terms, noting how the aircraft could circle a fixed position for extended periods, laying down fire along the perimeter with a precision of area coverage that felt less like traditional strafing runs and more like an invisible wall being drawn around friendly positions. This capability proved especially valuable during nighttime engagements, when enemy forces often attempted to press attacks under cover of darkness, and a circling gunship's sustained, saturating fire could hold a perimeter that a limited number of ground defenders might otherwise have struggled to maintain. Helicopter door gunners, meanwhile, used the weapon during troop insertions and extractions, laying down suppressive fire into tree lines and landing zones in the crucial seconds before and after a helicopter touchdown, precisely the kind of brief, high-stakes engagement window the weapon had originally been designed to address. If you're enjoying this one, a quick subscribe genuinely helps keep this channel digging into stories like it. Now let's look at how the minigun actually compares to the conventional alternatives, because the numbers are where its reputation truly comes from. Consider the standard weapons it operated alongside. The M60 general-purpose machine gun, firing at roughly 550 rounds per minute from a gas-operated action, was reliable, portable, and effective, but fundamentally limited by the mechanical constraints of a single barrel absorbing sustained heat. The M2 Browning heavy machine gun, a weapon that has remained in American service since before the Second World War, fires at approximately 450 to 600 rounds per minute, trading rate of fire for a much larger and more powerful 50 caliber round designed to punch through light armor and structures. Both of these weapons excel in their intended roles. Neither was ever capable of the sheer density of fire the minigun could generate in a short burst, because neither was mechanically built to survive it. Even against other rotary cannon designs developed around the same period, the minigun occupied a distinct niche. The GAU-8 Avenger, the massive 30mm rotary cannon later fitted to the A-10 Warthog, fired at a comparatively modest 3,900 rounds per minute, but each of its rounds weighed dramatically more and was designed specifically for punching through armored vehicles rather than saturating a wide area with smaller caliber fire. The minigun's 7.62mm rounds, by contrast, were never intended to defeat armor. They were intended to cover the maximum possible area with the maximum possible density of fire against personnel and light vehicles, a fundamentally different tactical goal that shaped every aspect of the weapon's design, from caliber selection down to its relatively compact size compared to larger rotary cannons. This is the core trade-off that defines the minigun's entire design philosophy. It sacrifices individual round power, portability, and ammunition efficiency almost entirely in exchange for volume, using overwhelming quantity to compensate for what a single well-placed shot from a more precise weapon might otherwise achieve. This trade-off is exactly why the minigun found its true home not in the hands of infantry, but mounted on aircraft and vehicles where its weight, power requirements, and ammunition consumption could be supported by the platform carrying it. A door gunner, engaging a target during a fast helicopter pass, has neither the time nor the stability for precise aimed fire. What that gunner needs is a weapon that turns a brief, imprecise engagement window into a near-guaranteed hit through sheer saturation. And that is precisely the gap no conventional machine gun could fill, and the minigun was purpose-built to close. The weapon's reputation only grew throughout the Vietnam War and the decades that followed. Special operations units adopted door-mounted and pintle-mounted miniguns for helicopter escort missions, valuing the psychological effect of the weapon's distinctive sound almost as much as its actual lethality. Enemy combatants who had experienced minigun fire described an almost otherworldly quality to the weapon's report, a continuous droning buzz entirely unlike the recognizable rhythm of conventional automatic weapons fire, and that unfamiliarity itself became a genuine tactical asset, disorienting enemy positions in the crucial seconds after an aircraft came into range. What is remarkable about the minigun, though, is not simply its Vietnam-era combat record. It is that more than 50 years after its introduction, the weapon remains in active American military service, still mounted on helicopters, still fitted to AC-130 gunships in updated form, and still issued to special operations units for specific mission profiles where volume of fire matters more than precision or portability. In an era where the American military has fielded guided missiles capable of striking a target from miles away with pinpoint accuracy, and where drone-mounted precision munitions can eliminate a single individual while leaving a building standing, the continued relevance of a weapon built entirely around the crude brute force principle of overwhelming volume might seem almost anachronistic, but the reasoning behind its persistence is straightforward once you consider the specific scenarios where precision alone cannot solve the problem. Suppressive fire during a close air support mission, where the goal is not necessarily to eliminate a single target, but to prevent an entire enemy position from returning fire during a critical window, still benefits enormously from sheer volume in a way that no single guided munition can replicate. A convoy under ambush, a downed aircrew awaiting extraction, a special operations team pinned down during exfiltration. These are scenarios where the ability to lay down a continuous, overwhelming wall of fire across a wide area buys time and cover in a way that precision alone cannot. The minigun does not need to hit a specific target with a specific round. It needs to make an entire area of ground too dangerous to occupy for the several critical seconds an aircraft is exposed. And at that specific job, more than 50 years of combat experience have found nothing that reliably does it better. Modern variants of the weapon have been refined considerably since Vietnam, with improved electric drive motors, lighter composite materials in some components, and improved ammunition feed systems that reduce the jamming issues that occasionally plagued earlier models under sustained fire. The weapon has also found its way onto modern armored vehicles and remotely operated weapon stations, allowing operators to fire the minigun without physical exposure to return fire, a capability that would have been unimaginable to the door gunners who first carried it into combat over the jungles of Vietnam. Special operations aviation units in particular continue to rely on minigun-armed helicopters for exactly the same reason their predecessors did decades ago. When a small aircraft needs to suppress an entire area with overwhelming force in the span of a few seconds, there are still remarkably few tools in the American arsenal that do it as effectively. The weapon has also proven remarkably adaptable to conflicts far removed from the jungle warfare that first brought it into service. During operations in Iraq and Afghanistan, minigun-armed helicopters provided close air support in terrain and combat conditions the weapon's original Vietnam-era designers could never have anticipated, from dense urban environments to open desert engagements at extended ranges. In each case, the same underlying tactical logic applied. A fast-moving aircraft needed a way to generate overwhelming, area-denying fire during the brief seconds it was exposed to enemy contact, and more than half a century of refinement had done little to displace the minigun from that specific role. Naval applications have also expanded over the decades, with minigun mounts appearing on small patrol craft and ship defense systems tasked with engaging fast-moving small boat threats, another scenario where precise, single-target engagement matters less than the ability to saturate an approach vector with overwhelming fire in a matter of seconds. There is a kind of irony in the fact that a weapon whose core mechanical concept dates back to a hand-cranked Civil War invention remains, in an electrically driven and considerably more lethal form, one of the most enduring pieces of hardware in the modern American military. Richard Gatling built his original weapon hoping, in his own words from the period, that its sheer effectiveness might actually reduce the number of soldiers needed on a battlefield and thereby reduce casualties overall. Whether or not that particular hope was ever realized, the underlying principle he identified, that overwhelming volume of fire, could solve tactical problems that individual marksmanship could not, has proven durable enough to survive more than a century and a half of changing warfare, changing technology, and changing doctrine. It is a strange kind of legacy for a 19th-century inventor to leave behind, one built not on a single triumphant battlefield moment, but on a mechanical principle so fundamentally sound that engineers 100 years later, facing an entirely different kind of war fought from helicopters rather than horse-drawn artillery lines, found themselves reaching for the same basic idea and simply building it better. Few weapons in military history can claim a design lineage that spans from the Civil War to modern special operations aviation, and fewer still remain in genuinely active frontline use across that entire span, adapted and modernized, but never fundamentally replaced. The M134 minigun's story, in the end, is less about any single battle or any single dramatic moment of combat, and more about a design philosophy that has simply refused to become obsolete. Precision-guided weapons have transformed how modern militaries fight, but they have never fully eliminated the specific tactical problem the minigun was built to solve: the need, in certain narrow and often desperate situations, to turn a few seconds of exposure into an overwhelming, area-denying wall of fire. As long as that specific problem exists on modern battlefields, it seems the deadliest machine gun ever built will keep finding a reason to stay in service. If you want more deep dives into the weapons that have quietly stayed in service far longer than anyone expected, subscribe, and I'll see you in the next one.